Perfect. I just want to start by saying we really appreciate all of you that have joined today. We have a really interesting and I think important topic that sits right at the intersection of our increasingly data-centric and data-informed business models and the increasing need to keep data private. And so we thought we'd kick off today with a case study, a really famous example that illustrates both the benefits and the challenges of using anonymization as a core data protection technology. And that case study is the Netflix Prize. For those of you that are not familiar with the Netflix Prize, in the mid-2000s, Netflix was trying to improve its movie recommendation algorithm. They launched a $1 million prize as part of a public data science contest for teams that could improve the accuracy of their recommendation algorithm by 10%. And to power those teams and serve as the basis for this content, they released 100 million anonymous data points of historical user recommendation data. So how did users rate shows on a 1 to 5 star scale? And this was seen as an absolutely critical and innovative use of their internal data. So their recommendation algorithm was business critical. They saw it as the core anchor and advantage they had in retaining customers over time. And Reed Hastings said, right now we're driving the Model T version of what's possible. We want to build the Ferrari, and the Netflix Prize is the first step. So this was absolutely critical and valuable to Netflix to make sure that this contest was successful. And this kind of public data contest reflects something really important and something that a lot of businesses face today, which is that they have all these valuable data assets. And to maximize the value of that data, those data assets, they need to increase the number of people and the perspectives that can bring value and insights and create value from this data. It's not always the case that your internal machine learning team has all the answers and can get to the absolute best answer. Sometimes it's valuable for that team to be able to talk to the marketing team or the HR team about the specific context and bring new perspectives to their work. Netflix took that sort of out to the extreme by saying, we're going to release this data to the public and hopefully somebody can find some value here that we haven't been able to find. This was reflected in the CEO's comment that if we knew how to do it, we'd have already done it. So they were recognizing that a lot of times data democratization is essential in maximizing data value. And they recognized that releasing this data had potentially big implications on users' privacy. The vice president of their recommendation system emphasized that the company had consulted with experts. They had done everything they thought was necessary to make sure that this data could not be re-identified, couldn't be tied back to their real users, and acknowledged that like the real value that Netflix was hoping to extract came first and foremost from this data set that they had accumulated. And so it's not the case that they went into this challenge, they ignored privacy, and there was a big privacy breach. The problem arose when some researchers showed that despite these protections, the data could be re-identified. 99% of users could be uniquely re-identified if there were 8 movie ratings from that same user in the data set. This was ultimately fatal to the long-term success of the Netflix prize. Ultimately, they shut down the effort and had to settle a multi-million-dollar class action lawsuit alleging that the data was inadequately anonymized, and as a result, releasing that data constituted a breach of their obligations to their users. So the question is, how did these researchers re-identify this data that Netflix was confident was anonymized? And the answer is they were actually able to take Netflix ratings data, which was private, and correlate it to IMDb review data, which was public. So users who rate a movie 4 stars on a given date on Netflix are highly likely to rate that same show with the same rating around the same date on IMDb. And so by cross-referencing these two data sets, these researchers were able to re-identify the data. And this points to just how difficult it is to adequately anonymize data to the level that it can be released to the public, that it can be actually treated as non-sensitive information. It's not just that you have to be able to re-identify users based on the specific content of the data set, but you have to consider all of the other data that's available to potential adversaries, including public data and including data about these users that is potentially held privately by a potential adversary. And the real sort of tragedy from Netflix perspective of this is that the initial results of the Netflix prize demonstrated success. 2 teams were actually able to show a 10% uplift on recommendation quality based on this data set, but the privacy issues killed the project. And this is a pattern that we see repeating inside almost every company. The sort of process and pattern is they have proprietary but sensitive data. In order to extract the valuable insights in that data, they need to broaden data access so that more diverse perspectives can be brought to where is the meaning in this data actually going to be found? What is the data actually capable of telling us? And as they attempt to broaden data access, they run into the increased risk of data breaches, increasingly complex data governance and data access procedures, and ultimately highly reduced or highly increased time to value for these machine learning projects that have to go through a full compliance and governance review. Many companies have tried to solve that sort of privacy and compliance bottleneck by anonymizing their data. However, it is difficult. Netflix shows us just how difficult it can be to do this. And as a result, it has been really hard for organizations to overcome this privacy and compliance bottleneck using anonymization. So what does the privacy bottleneck actually look like? As data becomes more broadly available, it is increasingly important to put increased scrutiny on data access requests, even by internal teams, but especially for external data sharing. That means that we often see multi-stakeholder data governance and access processes that include legal, compliance, data owners, data custodians, IT, and security reviews. The result of this is that the time to value for data research and machine learning projects and data sharing and data commercialization projects is delayed tremendously. These are potentially 6 to 9 month data access processes in some large mature organizations. And while these process-oriented protections are valuable and reduce the risk, they do not eliminate the risk that some data will end up in the wrong hands or will be used incorrectly and create the risk of fines, breaches, and bad publicity. So anonymous data has tremendous potential to solve this bottleneck. But what does that actually mean when we say anonymous data? Netflix said their data was anonymized. What it means from a regulatory standpoint is that the individuals present in a data set can no longer be identified. And in making that determination, you have to think about what other data is available, how unique are individual records in this data, and come up with a rigorous, quantifiable way to support the idea that your data is anonymous. The reason that achieving anonymity is so valuable is that modern data protection laws don't actually even apply to anonymous data. And this is tremendously valuable. So if that data is accidentally breached, if it is used for a secondary purpose, identifiable data, if those things were to happen, would cause non-compliance and risk of breaches and fines. Anonymous data is not subject to the same restrictions and legal requirements. And ultimately, that means there are no limitations on the use of anonymous data. This data can be sold or shared much, much, much more easily to create direct revenue, as well as supply chain efficiencies in your business. It eliminates the requirements for regulatory audits and privacy impact assessments. And finally, even if the data leaks out, it is not considered a breach or a misuse of the source data. And so if we think about what that means in terms of alleviating the bottleneck, you get tremendously more efficient governance and access processes, faster time to value, which means incremental return for data research and ML projects, and finally, less risk. So you can both accelerate time to value and reduce risk simultaneously if you can anonymize your data. But as we saw with Netflix, that is not a trivial challenge. One important development since the Netflix prize, though, is that technology to anonymize data has improved tremendously, and particularly synthetic data can help organizations achieve anonymization at scale for complex data and to a much higher level of reduced re-identification risk and regulatory exemption. So the way that synthetic data allows this sort of scalable anonymization that is otherwise extraordinarily difficult, it does that by creating fictional lookalike populations. So in the Netflix example, rather than 100 million real users' reviews, a synthetic data set might contain the same number of users and the same number of reviews, except the users would be fictional and the reviews wouldn't tie back to individual real users. So you can use this data to extract the same insights, but because it doesn't tie back one-to-one to real users, it is much, much, much more difficult to re-identify this data and lose the protection of anonymized data exemptions. This graphic on the left was my attempt to use Midjourney to generate a synthetic population. If you look really closely, you'll see that these people can't be real. The mouth isn't always in exactly the right place, But what you get is a sense of what this population of people looks like. And so there are sort of 3 key jobs to be done for synthetic data, and this is what we do at Subsalt. The first is that the synthetic data has to be safe, which means it meets the regulatory definition for anonymization. The second is that it has to be useful. It has to be sufficiently statistically similar that data scientists and machine learning teams can use this data for exploratory analysis, for model training, and for other parts of the research and data science supply chain in lieu of real data. And finally, it has to be easy. So if it's impossible to actually get this synthetic data created at scale, then this is just going to be, sort of an offshoot of how you actually protect your sensitive data. So we'll dig into each of these 3 in sequence. From a safety perspective, it is critically important to align the quantitative and technical evaluation of re-identification risk with a legal opinion verifying that those technical metrics align to applicable regulatory standards for anonymization. This is something that we do inside of our product. So every synthetic data set produced by our product comes with 3 key artifacts. The first is a third-party statistical audit of re-identification risk that is produced by simulating privacy attacks on the synthetic data. That audit determines the acceptable levels of re-identification risk as measured by a set of standard metrics from this third-party auditor. The second component of this is a legal opinion verifying that the tests and thresholds defined in that audit align to the regulatory definitions of anonymization, such that if those thresholds are met, the data can be considered anonymized for the purposes of regulatory compliance, exemption, excuse me. And finally, we indemnify our customers against the risk that that our system makes an error and doesn't meet those quantitative requirements. The full picture is we take responsibility for aligning the technical, legal, and liability components of anonymization at scale on our customers' behalf. The second test is that the data has to be sufficiently statistically similar that it can be used in lieu of real data for common analytical tasks. And so the best way to measure this is by doing A/B tests of, at least in a machine learning context, is to do A/B tests of models trained using anonymous synthetic data and models trained using real data. We were able to do this comparison with a national insurance provider using their claims data to detect fraud, waste, and abuse. Our results showed that a model trained on Subsalt's anonymous synthetic data achieved 95% or greater performance relative to models trained on the real data, and in some cases actually even perform better than models trained on real data, because the synthetic data avoids some overfitting problems that sometimes happen with unusual distributions in real data. And finally, it is super important that anonymization be a component in the infrastructure stack for organizations. It's not sufficient to make it sort of a capability off to the side. If you want to achieve the benefits of anonymization at scale across projects, it's important that it connects to where the real data actually lives, that it preserves the security throughout the synthetic data creation process, and finally, that the downstream tools and systems that your machine learning and data science teams already use can easily access and consume this data, so that you don't have to fork your entire data stack in order to work with anonymous data. It's more like a bump in the road than a fork in the road. And if you achieve these three requirements, you can move unbelievably faster. This is an example from an actual customer implementation we did. They hit this data privacy bottleneck. And what they were seeing was data provisioning times, data access processes that lasted as long as 6 to 9 months. This was frustrating and slowing down their data science teams, their machine learning teams, who were spending all of their time in meetings and review committees, navigating red tape and process. We were able to work with that group and reduce their data provisioning time down to 1 day through leveraging anonymous synthetic data. And by the way, that data created less enterprise security and privacy risk than the data those teams were using before. And so the benefits of this are enormous, particularly for those data leaders, machine learning leaders, who are trying to demonstrate value quickly and provide a great experience for their teams, who fundamentally want to be doing data work, not navigating internal sort of opaque and arcane internal processes. And when you add all this up, there's an enormous opportunity for organizations to leverage anonymization as a core data protection mechanism as they run into the challenges of complying with, I think we're now up to 15 state privacy laws, including some that are specific to health data or financial data or employment data. Increasingly, those privacy laws, as well as the sort of current aggressive stance from the FTC, is going to make it more difficult to democratize data, to take advantage of more diverse perspectives and expertise as organizations try to turn their proprietary data into a competitive advantage. And this is the solution. Anonymization is the solution to unlock that data, accelerate the transformation to a more data-informed and data-centric operating model without increasing the process, documentation, and time overhead of navigating these new legal and regulatory requirements around data privacy. And so this is the way that organizations whose data is regulated, confidential, or sensitive can move just as fast as the organizations who are not subject to these laws and restrictions. And so this is the sort of work that we do at Subsalt, is to help organizations take advantage of this anonymized data opportunity and not get caught in the sort of data privacy bottleneck that we discussed before. So that's kind of the end of the prepared content, and I will stop sharing and jump back on here.
Thanks, Ben. We've got one question in the chat, and then I've got one that I wanted to tee you up with because we get it all the time. But let's start with the chat first. Looks like from Jorge Fernandez around structured and unstructured data. Are we talking strictly about tables with numeric data, or does this also include long texts within a table? Can you expand upon that a little bit?
Yeah, absolutely. So this is a solution that works scalably and reliably for tabular structured data, so that it doesn't all have to be sort of continuous float variables, but it is not yet something that works exceptionally well at scale for unstructured data like text, right? So the basic challenge of anonymizing data in this way, where the data is unstructured text, is that it's very difficult to determine what information is actually being disclosed in a piece of unstructured text, structure that data such that you can evaluate how unique the privacy risks are, and then mitigate those privacy risks. I think this is an area where there's a lot of evolution and development. The pace of, as you can imagine, LLMs have really sped up the possibility of anonymizing data in free text, but it's not something that is as mature or reliable yet as leveraging synthetic data for structured tabular data, which means that, you know, a lot of the workflows where you can really take advantage of synthetic data today are more traditional machine learning recommendation system kind of use cases versus the sort of LLM governance and LLM privacy issues where you expect the sort of input and output data to be unstructured.
Yeah, exactly. Jorge, thank you for bringing that up because we do get that in conversations, I'd say at least once or twice a week right now. So I'm glad we could expand upon that. Ben, one other question I wanted to bring up for you that comes up a lot in conversations around synthetic data. And you said the word anonymized and synthetic about 100 times over the last 30 minutes. So I figured I'd ask this specifically. Isn't synthetic data anonymous by default?
Yes, that is an excellent question. And the answer is
Thank you. I've been
no.
thinking about it all morning.
You ask great questions. So the answer is no. It is not automatically anonymous. The process of breaking the one-to-one relationship between real records and synthetic records provides a really high baseline level of privacy. But there are still re-identification risks in synthetic data. Those risks fall into sort of three buckets. The first is, do the synthetic records contain records that are overfit to real records? In other words, does your synthetic generator reliably produce real records or records very similar to real records as part of the generation process? So you need to make sure that you are not producing a bunch of rare records that are statistical matches to real records in your synthetic data set in order to ensure that you're not leaking private information. The second one is called membership inference. So there are tests to determine whether a user record in the input data set was used to train a synthetic data generator. So can you determine that an individual was in the training set for the synthetic data? That would be considered a re-identification under these laws, and it's a risk that has to be explicitly measured and managed. And then the third kind of risk inherent to synthetic data is called attribute inference. So if you knew that an individual was in the training set, could you learn something new about that user by looking at the synthetic data set? So the example I always like to give for this one is if you were to look at hospital records in Charlotte, North Carolina, where Phil and I live, you might have one record where the person is over 7 feet tall. If that record's in the training set, you may end up with a synthetic record of a user who's 7 feet tall. The problem is that if there's a 7 foot tall person in the output data set, there's a pretty good chance that it's one of the two. It's either the starting center or the backup center for the Hornets. And if in that data set, that 7 foot synthetic record has an STD on their medical record, right? You can actually learn something about the real person in the training set by looking at that synthetic data set, because there's just one of them in the input data set. That record is really rare, and it's going to disclose some new information. So you have to pay really, really close attention to the information you're disclosing about small and rare populations. This comes into play with rare diseases, and like I said, 7 feet tall people. There just aren't enough of them to protect their privacy without some very explicit protections, even where you're creating synthetic data.
Very true. Not too many 7 feet tall individuals in Charlotte today, but we'll see. We actually have another question that just came in. So can synthetic data, I'm assuming, be leveraged for a data workflow where you're taking data from multiple tables into a graph to then train a graph neural network? Does it preserve that specific level of a relationship?
Yeah, so this is a relatively complex technical question. The basic answer is that we can handle multi-tabular data structures, and we can output joined data sets from those multi-tabular data structures. We would probably need to get into the specific details of how you're pre-processing that data prior to training, and sort of do some solutions engineering around precisely how we connect to those tables, what are the intermediate formats, how do we get them into the form you need to train. But as a general matter, we can support multi-tabular or even multi-data source workflows in creating anonymous training sets.